Okay, this is the second part of the lesson on operating with polynomials. And now we're going to look at how we divide polynomials. Now, division's a little trickier than addition, subtraction, and multiplication, so that's why I recorded this as a separate video. Let's divide two polynomials. So I've got the polynomial f of x, which is x squared plus 8x plus 1, and then a polynomial g of x, which is the function x plus 4. Alright, so what we're going to do is we're going to divide f of x by g of x. Now, in order to understand this, let's go back to elementary school. And so in elementary school, you learned how to divide using long division. So say we said, this is our elementary example. How do I spell elementary? Elementary. There we go. Here's our elementary example. What if I said divide 47 by 3? So in elementary, you would have set up long division. You would have said 47 divided by 3. And then we go and say, okay, 3 goes into 4 one time, then we multiply, 1 times 3 is 3, we subtract and bring down the next number, and we start the process again. 3 goes into, well, 3 doesn't go into 1, so we asked, does 3 go into 17? Yeah, 3 goes into 17 5 times. 5 times 3 is 15. Then we subtract, that's 2. And if there's nothing to bring down, that means that's my remainder. So the answer is 15 remainder 2. Yeah, that makes sense. 47 divided by 3 goes in 15 times, and we have a remainder of 2. Okay, if we remember that, we can divide polynomials. It's the same process. Okay, so we're going to do f of x divided by g of x. Well, that's x squared plus 8x plus 1 divided by x plus 4. So I'm going to set this up in long division. I'm going to title this long division, and you should on your notes as well, because I'm going to show you a couple ways how to how to divide polynomials. One way is by doing long division. It's analogous to what we just did in elementary school. So I put the x plus 4, the divisor, on the outside. Then I put the dividend underneath the division kind of symbol. Alright, so let's talk about how I can divide using polynomials. So I look at the first term x squared, and I divide it by the first term x. X squared divided by x is x. Then I multiply x by each of the terms in my polynomial. X times x is x squared. X times 4 is 4x. Well, after we multiply, we subtract. So I subtract x squared minus x squared, well, that's 0. 8x minus 4x is 4x. And I bring down the next number, plus 1. Then we repeat, do the same thing. So I look at the first term, 4x, and divide that by x. 4x divided by x is 4. Then I multiply. 4 times x plus 4 is 4x plus 16. And I subtract. 4x minus 4x cancels. 1 minus 16 is negative 15. There's nothing else to bring down, so negative 15 is my remainder. So the answer, x squared plus 8x plus 1 divided by x plus 4, well, that's equal to x plus 4, remainder, negative 15. Kind of box this out so we know it's not part of the problem. Okay. Alright, well, that's kind of confusing. And, oh, I'm going to pause.
Thank you.
You're welcome. Alright, back to it. Where were we? Yes, okay, long division. It's a little tricky. There's actually a faster way, an algorithm that we're going to use that's going to help us do this much faster. And it's called synthetic division. It's doing the exact same thing, but it kind of uses an array that makes it a little bit easier. So if we're dividing x squared plus 8x plus 1, we'll do the same problem. If we're dividing that by x plus 4, let me show you how to do synthetic division. We set up a little bracket like this, and on the outside we put the number that we're dividing by. Well, we're dividing by x plus 4. So I'm going to write the number -4. It's always going to be the inverse of the constant term. So this is plus 4. The opposite of plus 4 is -4. We write that there. Then we write the coefficients of the number we're going to divide. So that's our dividend. We're going to write the coefficients, so 1, 8, and 1. These came from the coefficients of this, 1x squared plus 8x plus 1. Now, all you do now is you add down and multiply. So I bring the 1 down, and then I multiply by -4. -4 times 1 is -4. I add straight down. 8 plus -4 is 4. Then I multiply. -4 times 4 is -16. Then I add straight down. That's -15. The last number is your remainder, and then this is your answer. So it's 4, and then that's our constant term, so this is our x term. So the answer is x plus 4 remainder -15. Okay, we'll do a couple of these examples. Okay, so here's another example of synthetic division below. Let's do x cubed plus 5x squared minus 7x plus 2 divided by x minus 2. Okay, so using synthetic division, I'm going to draw my little synthetic division bracket. On the outside, the number we're dividing by, I write the opposite of -2, that's positive 2, and then I write the coefficients of the dividend here. So it's 1x cubed plus 5x squared minus 7x plus 2. And we bring down the first number, multiply, then add. So 2 times 1 is 2, add 7. 2 times 7 is 14, add 7. 2 times 7 is 14, add 16. The last number is the remainder. Then we go constant term, x squared term. So my answer is 1x squared, which is x squared, plus 7x plus 7, remainder 16. Okay, let's do one more. Okay, we're going to do x to the 4th plus 4x cubed plus 16x minus 35. We're going to divide that by x plus 5. Once again, we start by setting up our synthetic division bracket. The number on the outside is the opposite of positive 5, so -5. And then we write the coefficients of the dividend here. So I've got 1x to the 4th, 4x cubed, 0x squared. Notice that there's no x squared term here. You have to write 0 because the coefficient of x squared is 0. Then I have 16x, and my constant term is -35. Alright, now once again the algorithm is to bring down the first number, and then you multiply and add down. And just keep repeating that process. Multiply. -5 times -1 is 5. Add down, 0 plus 5 is 5. -5 times 5 is -25. Add down, 16 plus -25 is -9. Multiply -5 times -9 is positive 45. -35 plus 45 is 10. The last number is my remainder, constant, x term, x squared term, x cubed term. So my answer is, the quotient is x cubed minus x squared plus 5x minus 9, remainder 10. Okay, that's how we divide using synthetic division. You will only be responsible for knowing how to do synthetic division. You will not have to do long division. Over the next few days, we'll learn why this is useful, and honestly, synthetic division, being able to divide, we're going to see is a tool that's going to help us solve polynomials. It's critical that we know how to do synthetic division. Super important, and we'll learn that over the next few days.